All right, now let's use what we know about the Weidemann-Franz law to consider what the temperature dependence of thermal conductivity for a metal should look like. So, does it have a temperature dependence? Well, let's use Weidemann-Franz law and see what it says. So for a pure metal, near room temperature, meaning, which would be considered at high temperature for most metals, the resistivity typically goes linearly with absolute temperature. So resistivity increases with temperature almost linearly. And if I plug that into the Weidemann-Franz law, what it says about the thermal conductivity is that, the temperature dependence of the resistivity cancels with the temperature dependence that appears in the Weidemann-Franz law to produce a constant, meaning that the electronic portion of the thermal conductivity is predicted to be independent of temperature. And that is in fact what you find for common metals like copper, aluminum, iron, like steel. Most of these things have a thermal conductivity that is independent of temperature, and that's the reason why. In fact, the only time that doesn't happen is when a metal is either impure, meaning that electrons scatter with things like grain boundaries rather than with phonons, for example. And that typically happens either at low temperatures or for very impure things. So in that case, what you find is that the electrical resistivity is roughly independent of temperature, which according to the Weidemann-Franz law implies that the electronic portion of the thermal conductivity scales linearly with temperature. So at low temperature, typically the electronic portion of the thermal conductivity scales linearly with temperature. So in summary, what we found is that at high temperature, where electrons primarily scatter with phonons, the electronic portion of the thermal conductivity is independent of temperature. But whenever the electrons are primarily colliding with impurities, the electronic portion of the thermal conductivity scales linearly with temperature. Sometimes that can be done on purpose by alloying a material to make lots and lots of impurities. And that in that case, that would be called a dirty metal.